Okay, so back to the binomial estimates. One of the questions from the test paper said find the binomial expansion of 16 minus 6x to the power of 3/4. And then we had to estimate the value of 19 to the power of 3/4. Right, so what do we need to do? One, we need to expand. Okay, so when we expand, we've got 16 minus 6x to the power of 3/4, which is the same thing. We're going to take this out and make it 1 plus x. So then we take out 16 to the correct power. 1 minus 6 over 16x to the power of 3/4. Then we work out what this actually is. Okay, so let's take the 4th root of 16. That's 2. 2 cubed. That's 8. So that means this is 8 times 1 minus, and we can simplify this. That's 3/8 over 3/4. Excellent. Right, so that gets us our first mark. Okay, and we've got this written, so now it's easier to do our expansion. So the expansion is equal to 8 times the expansion of 1 minus 3/8. So we just put it into our normal format. 1 plus n, which is 3/4 times our x. Oops, x is out. X is minus 3/8 x. And then we add our n, which is 3/4 times minus 1. 2 factorial, and that's going to be times minus 3/8x, now all squared. We're only interested in the x squared term. So then we multiply all of that out, and we end up with 8 minus 9 over 4x minus 27 over 256 x squared. Right, we're only interested in the x squared term. Okay, so we've done that. Now B, sorry, 2. So the next thing we need to do, valid range. Okay, remember, there's only a certain range that x is valid in, so that basically it converges to what we can estimate the value. So we've got 16 minus 6x. We don't want it to be 0, because if it's 0, it's not going to tell us anything. So if we do that, that means that 16 equals 6x, and therefore 16 over 3 equals x. Or simplify that. So 16 over 6, so that's going to be 8 over 3. So we can say that it's valid if the modulus of x is less than 8 over 3. Because at 0, that's going to be, so if basically is equal to 8/3, that's going to be equal to 0. Okay, so basically we're going to basically set it less than that 3. Now we have to find the value of x for the estimate. Now we've got 16 minus 6x to the power of 3/4, and we're trying to estimate 19 to the power of 3/4. Well, look, they've both got the same power. Okay, so let's just say that 16 minus 6x equals 19. Okay, and if we do that, that means that 6x equals 16 minus 19 equals minus 3. So that means that 1x is minus 3 over 6, or minus a half. Right, so this should be our value of x. So what we do, we substitute that in. So 19 to the power of 3/4 equals 8 minus 9 over 4 to the power minus a half, minus 27 over 256 minus a half squared. And that gives us 93171024. Okay, now the value of, if we put it into a calculator, okay, the exact value this is equal to 9.098632813. As you can see, they're very, very close. Remember, with the expansion, we've only gone as far as the x squared term. Okay, so remember the difference that if I substitute a value into this, if I sub in x to this, this is the exact value, because this is the nth term for the series. If I substitute a value into my expansion, that gives me an estimate, okay, because my expansion is not going to be the exact value. What we're doing is we're using a value of x to try and get as close as we can. I'll post another video where it's not something to the same power and you have to use a perfect square to find the value of x.